The equation of a line is an algebraic equation representing the set of points on the line. If the point P is on the line L, then P is an element of the set L. In this module, we will look at various points of interest. We can determine if a point is on a line, we can find the x and y intercepts of a line, and we can find the point of intersection of two lines. To show or prove that a point is on a line, we can substitute the coordinates into the line equation. If the left-hand side is equal to the right-hand side, then the equation remains true. This shows that the point satisfies the equation and is therefore on the line. The x and y intercepts are the points of intersection of a line and the axis. The intercepts are found from the knowledge that when a line cuts an axis, the coordinates will be of the form x0 or 0y. The point A is the x-axis intercept, which we find by letting y be equal to 0 in the equation. Simplifying and solving for x gives the point of intersection as x0. The point B is the y-axis intercept, which we can find by letting x be equal to 0 in the equation. Simplifying and solving for y gives the point of intersection as y0. Linear simultaneous equations are a set of equations for which there is one coordinate that satisfy all the equations simultaneously. The coordinate is the point of intersection of the lines, and it can be found either graphically or algebraically. The graphical method involves plotting the lines on a coordinate diagram and reading the coordinate of the point of intersection from the graph. The algebraic method involves finding the coordinate using the method of elimination. This requires writing the equations over each other, and one of the variables, either x or y, is chosen to be eliminated. One or both of the equations may need to be multiplied by a constant to make the chosen variable equivalent. The equations are then subtracted, which will eliminate the chosen variable. The resulting equation can be solved for the remaining variable. This result is then substituted into one of the original equations to solve for the other variable. The solutions are then written as a coordinate and is the point of intersection of the two lines. In our first practice question, we must determine if the point P is on the line L. We do this by substituting the coordinates into the line equation for x and y. Simplifying gives us 0 equals 0. The left-hand side of the equation is equal to the right-hand side of the equation. This means the equation remains true. Therefore, the point P is on the line L. In this question, we must find the x and y intercepts of the line L. We will start by finding the x-axis intercept. We will substitute 0 for y into the equation. Simplifying and rearranging gives us an x value of -3. Therefore, our x-axis intercept is -3, 0. Next, we will find the y-axis intercept. We will substitute 0 for x into the equation. Simplifying and rearranging gives us a y value of -2. Therefore, our y-axis intercept is 0, -2. In this question, we must find the point of intersection of the two given lines. As they are both linear equations, we will use the method of elimination. We start by writing them over each other. The y terms are equivalent, so we will eliminate the y variable. Doing so gives us an equation which can be solved for x, giving us a value of x is 1. We will now substitute this x value into one of the original equations. Solving this equation for y gives us a value of 2. Therefore, our point of intersection of the two lines is the coordinate 1, 2. We are now ready to practice some past exam questions. When a question appears, please do pause the video and attempt the question. On resuming the video, you will see the answer fully worked and explained. In this question, we are told that the lines L and K intersect at the point P, and we are asked to find the coordinates of that point. As they are both linear equations, we will use the method of elimination. We start by writing the equations over each other. The y terms are equivalent, so we will eliminate the y variable. This gives us an equation which can be solved for x. The x value of 3 is now substituted into one of the original equations. This equation can now be solved for y. The coordinate of the point of intersection P is 3 and 5/2. Here we must find the point of intersection of the lines L and H. As they are both linear equations, we will use the method of elimination. Writing the equations over each other, we see that neither variable is equivalent. Therefore, we will multiply the second equation by a constant of 4. Rewriting the equations, we see that the y terms are now equivalent, so the y terms will be eliminated. As the signs of the y terms are the same, we will change the signs of all terms in the second equation by multiplying across by -1. Eliminating the y terms gives us an equation which can be solved for x. The x value of 7 is now substituted into one of the original equations. This gives us an equation that can be solved for y. The point of intersection of the two lines is found to be 7, 4. In this question, we are given the equation of a line and asked to show that the point 4, 1 is on the line. We start by substituting the x and y values from the coordinate into the equation. Simplifying gives us a result of 1 = 1. The left-hand side of the equation is equal to the right-hand side, which means the equation remains true. Therefore, the point 4, 1 lies on the given line.